In this video, I will walk you through two problems involving the applications of average rate of change and average value. Number 7 is a calculator active problem, so we will be using our graphing calculator as needed. At time t equals 0, a hose begins to fill an empty tank with water. The rate, in gallons per minute, at which the hose fills the tank is given by f of t equals 2 minus 2 cosine pi times the square root of t for the interval from 0 to 10. There are no leaks. Part A. Find the instantaneous rate of change in the amount of water in the tank at time t equals 5. Include units. Because there are no leaks in the tank, we know that the rate at which the hose fills the tank is the rate of change of the overall volume in the tank. So notice that F at t is what we normally call dV dt. It's the rate of change of the volume. So F at t is the same as V prime at t. So just keep that in the back of your mind. Part A. Find the instantaneous rate of change of the amount of water in the tank at t equals 5. So they are asking us to find the rate of change of the water, meaning the rate of change of the volume. Well, that's just f of t. So all they are asking for is f at 5. This is calculator active, so let's go ahead and put this equation into our calculator. Hit the y equals button. I will usually put the original function on y1, and I will put a rate on y2, and I will put the second derivative on y3. So I'm not sure what to do with f of t because they've written it sort of like the original function, but I know it's a rate. It's really like v prime. I'm going to put it on y2. It doesn't really matter. It just helps me keep track. But I'm going to think of this as the rate of change. So I'm really thinking of it as v prime. So I'm going to put it on y2. So we had 2 minus 2 cosine pi radical t. I'm going to use an x on the calculator instead of a t, but there it is. The function is written as y2. To evaluate the function, I am going to use the table feature. So normally I would hit second graph right now to access the table feature. But before we do that, I need you to adjust one setting for me. Hit second window to access the table setup menu. Second window. I want you to make sure that the independent variable is set to ask instead of auto. You can leave the dependent variable on auto. Then hit second table. So notice that we have y2 being mentioned right here. Because we set it to ask, we can type in any value we want for x, and it will give us the value of y2, which in this case is the value of f at t. We want the value at 5, so I just type in 5 and kabam! There it is, 0.525. If you ever need extra decimals, you can just highlight it and you see all of the decimals. But we're going to round to 3 decimal places, so 0.525. Don't forget the units. F at t, the rate is in gallons per minute. So gallons per minute. And that's it for part A. Part B. Find the average rate of change in the amount of water in the tank between t equals 0 and t equals 5. Include units. Remember, f of t is the rate of change of volume. Therefore, the average rate of change of the volume is just the average value of f of t. So really, we are just being asked to find the average value of f of t for the interval from 0 to 5. The formula for average value is integral divided by interval. the integral of f of t from 0 to 5 divided by the interval 5 minus 0. Of course, 5 minus 0 is just 5. And dividing by 5 is the same thing as multiplying by 1/5. So I'm going to go ahead and write this as 1/5 instead of divided by 5, just because it will be easier to type into the calculator. Let's start with that 1/5 that I just showed you. So 1 divided by 5, so 1/5. Next we need the integral from 0 to 5. You get that by hitting the math button, and then option 9 is integral. So hit that. We want 0 to 5. Type that in. We want the integral of this function f of t. I could either type in the entire function that we were given, all right? I could type in all of this, or I can remember that I just typed this function as y2. So I can just put y2 in here instead. How do I get y2 inside the integral? Well, use the vars button. Hit vars, and then shift over to the yvars menu and choose option 1. And here they all are. We want y2, so pick that. So y2 is the entire function f of t. So we're taking the integral of f of t, and just go ahead and put an x here. And that's it. Just hit enter, and this will be the answer. 1.637, I'm going to round up. The AP graders for the College Board will accept 1.636. You can truncate or round up, either way. Remember that the units of f of t were in gallons per minute, so the average value of f of t will still be in gallons per minute. Part C, find the amount of water in the tank at t equals 5. Include units. This looks like a job for the first fundamental theorem of calculus. We can use the first fundamental theorem of calculus to convert back and forth between the rate of change and the amount of something. So the end amount is equal to the initial amount plus the integral of the rate of change from A to B. We are being asked to find the volume in the tank at a certain time. So let's rewrite the fundamental theorem of calculus in terms of volume. The end volume should equal the initial volume plus the integral of the rate of change of the volume from A to B. We are being asked to find the amount of water in the tank at t equals 5. In other words, we need to find the volume at t equals 5. That will be the end volume. So let's put that into the formula. So we need the volume at 5. What about the initial volume? In the setup of the problem, we were told that at time t equals 0, the hose begins to fill an empty tank. In other words, the initial volume is 0. So let's modify this further. First of all, the initial time is time 0, so that's going to be my lower limit of integration. And my end time, as we just said, we want to find the volume at t equals 5. So that's my upper limit of integration, is that end time. And we know that the initial volume is 0. So V at time 0 is 0. So we can just go ahead and put a big old 0 right there. I want to make one other change because I'm using this variable v, and here I have v prime. But then the way they gave us the problem, they gave us this function f that we have to deal with. Now we have learned that this function f is the rate of change of the volume. So v prime is function f of t. So I can make that substitution as well. So here where you see v prime, this really is just f at t. And I guess I'll just go ahead and put the t's as well. So we have rewritten the fundamental theorem of calculus to match the problem that we have. But this is something that we can simply type into the calculator. When I type this in the calculator, I will not put the 0. It's going to be exactly what we did before, but this time without the 1/5 in front of it. So remember, for the integral, we hit math and then 9. And we want the integral from 0 to 5. And we are taking the integral of f of t, which we typed into y2. So we can access y2 by hitting the vars button, switch over to the yvars menu, choose function, and then y2. And go ahead and put in your x. Kabam! 8.183. For the units, we just found the volume of water in the tank at t equals 5. So this will be measured in gallons. Sadly, number 8 is a no calculator problem. The population of Townsville in thousands of people is given by P of t. Selected values of P of t are given in the table provided. Part A. Use the table to estimate P prime at 9. Include units in your answer. P prime at 9 is the slope of the function at t equals 9. However, we don't have an actual function, we can't graph it, we can't find the derivative of it, so we're unable to find the exact slope of the curve at t equals 9. However, P prime at 9 is approximately equal to the slope of the secant line near t equals 9. For example, from 8 to 10. When we talk about the slope of a secant line, we're just talking y minus y over x minus x. Or in this case, it's going to be the value of P at 10 minus the value of P at 8. So that's my y minus y over x minus x, which is 10 minus 8. P at 10 is 58,000 people. And P at 8 is 52,000 people. This simplifies to 6 over 2, which equals 3. But what about the units? Be careful here. Don't forget that the people on this chart are in thousands. So when we start talking about the rate of change of people, we are talking about thousands of people per year. So P prime at 9 is approximately 3,000 people per year. Or it might be more natural to write 3,000 people per year. Either of these is acceptable. Part B. Is it possible to find the average rate of change of P of t on the interval from 0 to 10 using the information on the table? If so, find it and include units in your answer. If not, explain why not. The answer is yes, we can find the average rate of change of P of t on this interval. In fact, we just found an average rate of change a moment ago. In order to estimate the value of P prime at 9, we found the average rate of change on the interval from 8 to 10, and we used that as our approximation. And what we found was that the average rate of change is just the slope of the secant line. So if we want the average rate of change on the interval from 0 to 10, we are going to find P of 10 minus P at 0 minus, over 10 minus 0. It's sort of like y minus y over x minus x. However, P of 10 is 58. So we have 58 minus, and p at 0 is 40, 40,000, technically, really, divided by 10 minus 0. So that simplifies to 18 over 10, which is 1.8. Now, how about those units? We are talking about the rate of change of a population. So we're talking about the rate of change of people. So normally we would talk about people per year, but we're not talking about 1.8 people per year. Remember, the numbers on the chart were given in thousands of people. So this is 1.8 thousand people per year. Or if we want to just convert this to the actual number of people, we can multiply 1.8 times 1,000. Multiplying by 1,000, you move the decimal point 3 times. So if I do that, I'm going to get 1800. All right? In other words, 1,800 people per year. Either of these answers would be acceptable. Part C, is it possible to find the average value of P of t on the interval from 0 to 10 using the information in the table? If so, find it and include units in your answer. If not, explain why not. We cannot calculate the average value of P of t. Average value equals integral divided by interval. And we do not have an equation for P of t, so we can't find the integral. I should say we can't find the integral because we do not have an equation or a graph. If we had an actual graph of P of t, we could calculate the integral from that. Part D, use a right Riemann sum and the 4 subintervals indicated to approximate the average value of P of t. Imagine that this red curve represents the population at time t from t equals 0 years to t equals 10 years. The integral of P of t from 0 to 10 would then be the area under the curve from 0 to 10. You can use a Riemann sum to estimate the area under the curve. When you do a right Riemann sum, you use several rectangles, but you draw them so that the right side of the rectangle is on the curve. The number of rectangles you will use to approximate this area will depend on the number of intervals that you use from your data. There are 4 intervals suggested by this chart. We have an interval from 0 to 4, and then one from 4 to 5, another from 5 to 8, and a fourth from 8 to 10. Each interval corresponds to a rectangle. For example, focus on the interval from 5 to 8. This represents a rectangle from t equals 5 to t equals 8. Ultimately, we need the area of this rectangle, and we know that the area of a rectangle is base times height. The base of this rectangle will be the width of the interval. In this case, 3. From 8 to 5 is 3. So the base of this rectangle will be 3, and we can find the base of the other 3 rectangles in a similar way. Now it's time to calculate the height of each rectangle. Remember that this is a right Riemann sum. So we must imagine that the rectangle is drawn so that the right side of the rectangle just touches the curve. In other words, the height of the rectangle will be the value of the function at the right-hand side. Looking at each interval, the right-hand side is this number in each case. Again, focus on the interval from 5 to 8. The 8 is the right-hand side. So the height of this rectangle will be p at 8. And looking at the chart, P at 8 is 52,000. So the height of the third rectangle is 52. Similarly, the height of the first rectangle will be the value of the function at 4, so that's 46. And for the second rectangle, it's the value of the function at 5, so that's 47,000 people. And for the fourth interval, the height of the rectangle is the population at 10 years. That's 58,000. We will estimate the area under the curve between 0 and 10. In other words, we will estimate the value of the integral of p of t from 0 to 10 by adding the areas of these four rectangles. We know that the area of a rectangle is base times height. So for the first rectangle, that would be 4 times 46. And then plus, for the second rectangle, 1 times 47, and so on. So this expression will estimate the value of this integral. But remember, we really wanted to estimate the average value, which was integral divided by interval. That's what this 1/10 is. So look back to the previous problem. Remember, we were doing average value, integral divided by the interval. So I need to actually divide all of this by 10, because now it's the average value. All I have to do is divide all of this by 10. So now we just need the units. The average value is not a rate. It's just the average amount. It's the average number. In this case, it's the average number of people. So the units will be in thousands of people, since our numbers from the chart were measured in thousands, but it's just a number of people. In addition to finding the average value, we are asked to explain the meaning of this value in the context of Townsville. This number represents the average population of Townsville in thousands from t equals 0 years to t equals 10 years. If you're curious, this number comes out to be 50.3 thousand people, or 50,300 people.